In this video, we're going to take a quick look at some Regents questions involving minerals and how can we use the ESRT, the Earth Science Reference Table, to help answer those questions. And so occasionally we have questions about minerals that actually aren't answerable using the reference table. Here's two great examples. And so the diagrams on the left-hand side, test A, B, and C, are all tests that you would commonly perform on minerals in order to figure out what mineral sample you're looking at. So in test A, the mineral has been hit on the side with a wedge. It could be a hammer, it could be anything, but it breaks apart into two separate flat pieces. So that is testing for the property of breakage known as cleavage. Test B, we're taking a mineral and we're rubbing it on a porcelain plate, leaving behind the color of the powder. By definition, that is a streak test. And then test C is a very common hardness test, taking a mineral, scratching it against glass, to see whether or not it leaves a mark. If it leaves a scratch, we say that the mineral is hard. If it does not leave any scratches, we consider the mineral to be relatively soft. So what we see here, test A is cleavage, test B is streak, and C is hardness. Okay, so question A is asking which sequence correctly matches each test, A, B, and C, with the mineral property tested. We've already got our answer. A is cleavage, B is streak, and C is hardness. So that is answer choice number 1. Right? And why do we test minerals in the first place? It's because we want to know what we're looking at. That is best described by 2, identity of the minerals. The key point here, identity of minerals, the word identity just means to name. So if you're looking for the identity of something, you're looking to name it. So here's a question that actually does require the Earth Science Reference Table. So which mineral leaves a green-black powder when rubbed against an unglazed porcelain plate? And so good idea is always to sort of identify what is the question asking and what information does it give you. And so I'm going to demonstrate by putting a box around what is the question asking for, name of a mineral, and it gives us the fact that we have a green-black powder, also known as streak. So which one of those 4 options, galena, graphite, hematite, or pyrite, gives us a green-black streak? So if we take a look at the Earth Science Reference Table, we have graphite, galena, pyrite, and hematite. And in order to find the streak, we're going to take a look at the distinguishing characteristics. Graphite has a black streak, galena has a gray-black streak, pyrite has a green-black streak. And that's what we're looking for. Just to round things out, hematite has a red-brown streak. And so which mineral leaves a green-black streak? That's pyrite. So we looked under the distinguishing characteristics and figured that out. Another example involves hardness. And so hardness is on the second column of the reference table. So here we're looking for which mineral scratches dolomite and is scratched by olivine. So the first thing we need to do is to identify the hardness of dolomite and the hardness of olivine, because we know our mineral is harder than dolomite but softer than olivine. And so first thing to do is figure out that dolomite is a hardness of 3.5 and olivine has a hardness of 6.5. So the mineral we're looking for has a hardness between 3.5 and 6.5. The next thing, we can take a look at our options. We have galena, we have quartz, potassium feldspar, and muscovite. And so first thing, we look at galena. Galena has a hardness of 2.5. That's outside of our range. We look at quartz next, because it's the second option in our list. Quartz has a hardness of 7. That's too hard. It would not be scratched by olivine. Then we take a look at potassium feldspar, our third answer choice. Potassium feldspar has a hardness of 6, which falls within the range in between dolomite and olivine. So dolomite has a hardness of 3.5, olivine has a hardness of 6.5, potassium feldspar has a hardness of 6, which is greater than 3.5 but less than 6.5. If you're wondering, muscovite mica has a hardness between 2 and 2.5. So it is on the very soft side of the spectrum here. Another hardness question. Okay, so which statement best describes? This is a little bit of a different type of question. So this particular question is asking which one of these 4 statements on the right is true, or kind of is the most true. So that's what we're looking for, and we know the hardness of the mineral dolomite. All right, so we take a look at dolomite, we go across the table, we see its hardness is 3.5. So we know dolomite has a hardness of 3.5. So knowing that, dolomite would fit in right between the copper penny and the window glass. It's going to scratch the penny in the fingernail, but it will not scratch the window glass or the steel nail. So reading through our options, dolomite can scratch window glass. That's just not true, because window glass has a hardness of 4.5, which is higher than 3.5. So 1 and 2 are gone. They're bad options. Dolomite can scratch a copper penny. That's true. It'd be a little bit tough to do, but you could scratch it, but cannot be scratched by a fingernail. So that's true. A fingernail will not scratch any of these other objects because it's softer than all of the other objects on the page. So the correct answer is choice number 3. Another example, this uses or looks at the uses of minerals. So we're looking for which home building material, and we know that it's made from gypsum. Right, so is it plastic pipes, window glass, drywall, or iron nails? So in this case, we're going to be using the uses column of the minerals, particularly gypsum. Right, so that's the mineral we know. Gypsum is used in plaster of Paris as well as drywall. So we go back to the question, drywall panels is our third and correct choice. Right? A little bit more complicated example. So we have a table that gives us a bunch of different physical properties of minerals, so including the color, the hardness, characteristics, as well as the cleavage and fracture. Right? And it is asking us what elements make up this particular mineral. And as was stated before, we know all about the color, the hardness, distinguishing characteristics, and cleavage and fracture. Right? So using these pieces of information, something that stands out to me is that it feels greasy. That would be under a distinguishing characteristic. And I know the hardness of calcite is 3. So I know this has a very low hardness if it's scratched by calcite. I also know that it has cleavage because of the flat surfaces here. All right, so I'm looking for a soft mineral that feels greasy. So on our Properties of Common Minerals chart on page 16, it's the back cover, the reference table. Under distinguishing characteristics, I'm going to look at feels greasy. I see that for graphite, but the color's wrong. It's silver to gray. I'm going to keep looking till I see greasy feel. It's white to green in color. It's scratched by calcite. So we're looking at the mineral talc. Okay, so that has Mg3Si4O10 and OH2. So these are all of the elements in here. Mg is an element, Si is an element, O is an element, as is H. All right, so there's 4 different elements in here. If you don't know what these symbols stand for, you can always look at the bottom of the chart. So Mg is magnesium, Si is silicon, O is oxygen, and H is hydrogen. So looking at our options, we have oxygen, silicon, hydrogen, and magnesium. Correct choice is answer 3. Another example of using the uses column on the back page of the reference table. Which mineral, that's what we're looking for. And we know that it's mined for its iron content. So we're looking at hematite, fluorite, galena, or talc. So under the uses, we're going to look for material that is an ore of iron. So we have hematite and magnetite are ores of iron. So which is mined for iron content? It's hematite. Right? Fluorite is used for hydrofluoric acid, and talc is used in ceramics and paper. Galena is also an ore, but it's not an ore of iron, it's an ore of lead. So the correct answer is choice number 1, hematite. And here is another question. So this question is actually an example of something that you do need to know. This particular question is asking about the internal atomic structure of a mineral and what it most likely determines. I stated in a previous video that the atomic structure of a mineral determines its physical properties. So that's what this question is getting at. You need to know that the atomic or the internal structure dictates or controls all of the physical properties of a mineral. So we're looking for the answer choice that includes physical properties. Hardness is a physical property, cleavage is a physical property, as is crystal shape. So the correct answer choice here is answer choice number 1. Origin exposure are not physical properties. Size and location are not physical properties. Neither is age. Answer choice 1 is the only option that gives us 3 different physical properties, which are all controlled by the internal structure.